In this video, we're going to be learning about distance, speed, displacement, and velocity. Basically, we're starting motion. Motion is an object change in position. Motion is always relative to something. For example, we will always be comparing our motion to the ground. However, technically the ground is moving because the Earth is rotating. However, we'll just be comparing our motion to the ground as if the ground is not moving. Distance is defined as how far something travels. So in the SI system, remember the metric system, the units are meters. Time, SI units are seconds. You know, time is how long something takes. Speed is how fast something moves. Generally, we'll be using meters per second, but units for speed just must be a distance unit over a time unit. So normally we do miles, a distance unit, over hours, which is a time unit. You could technically do leagues over fortnights. League is a distance measurement. A fortnight is a time measurement. You could do nanoseconds, or you could do light years per nanosecond. So light years is a distance unit, nanoseconds as a time unit. Generally, you just want to do speed units that make sense for what you're measuring. The formula for speed is distance over time. You can write that as V equals D over T. Now V stands for velocity, and it's just easier than S because S stands for seconds. We're going to do some guided practice speed problems together. Number 1. Suppose Jessica rides her bike at a constant speed and covers 11 kilometers in 1 hour. What is her speed? Include units. The way I always want you to do these problems, even if it seems like a waste of time, is write out the formula. The formula is V equals D over T. So D, remember, stands for distance, T for time. What distance does Jessica cover here? She covers 11 kilometers. So 11 is going to go right here. And how long does it take her to do that? Well, it takes her 1 hour, so 1 is going to go right here. And 11 divided by 1 is just 11. Are we done this problem? No, we are not. We need to include units. In this case, the units are kilometers per hour, so we just write km/h. Now our problem is complete. Number 2. A student practicing for a track meet ran 250 meters in 30 seconds. What is her speed? Include units. So again, just start by writing the formula. We want distance over time. What distance did this student go? Did she go 30? No, because seconds is for time. Meters is for distance. So we want this 250 here for D. And then we want the 30 seconds in for T. So we have 250 divided by 30. And I'm going to round to 2 decimal places, so we get 8.33. Now, are we done this problem? No, we are not. We need our units. Are our units kilometers per hour? Are we right? No, our units are not kilometers per hour. That's wrong. They are meters per second. So now we are done this problem. Number 3. If it takes Ashley 3 seconds to run from the batter's box to first base at an average speed of 6.5 meters per second, what is the distance she covers in that time? Include units. So, V equals D over T. I want to point out here that we are not looking for speed this time. We are given speed right here. So this 6.5, we're actually going to plug in right here for V. we are looking for distance. Remember, the question asks, what is the distance? So we're going to leave d as our variable, like in math class, like when we're solving for x. But in this one, we're solving for d. And then 3 seconds, where does that 3 go? Well, seconds refers to time, so 3 is going to go in here for t. So we've got 6.5 equals d over 3. We need to use our algebra skills here. We want to end up multiplying both sides by 3. So that would cancel out. So we'll end up with d is equal to 3 times 6.5, which is equal to 19.5. Now, are we done this problem? No, we are not. We need to include units. Is that right? Do you say I traveled to my school 19.5 meters per second away? No. So meters per second, that's the units for speed. So what are the correct units for distance? Well, the correct units for distance are meters. Now we are done that problem. Okay, just a couple more. And even though these two don't say include units, we still want to include units. Number 4, Bart ran 5,000 meters at a speed of 5.5 meters per second. How long did he run for? So let's just start out by writing the formula. 5,000, that's meters. Since it's meters, refers to distance. 5.5, is that the time? No, because it says 5.5 meters per second. That means, and it also says it's the speed. So this 5.5 would go in for v. The problem asks us, how long did he run for? In this case, how long refers to the time. So we're going to leave time as our variable here. So we have 5.5 equals 5,000 divided by t. Now again, we've got to break out our algebra skills here. If we multiply both sides by t, then that cancels out on this side, and we will end up with 5.5t equals 5,000. Then we can divide both sides by 5.5. And we end up with t equals 909. Are we done with this problem? No, we are not. We need to put our units in here. Now, in this problem, we're looking for time, and we're given the speed in meters per second. So our time unit there is the second. Number 5. Florence Griffith Joyner ran 0.1 kilometers in 10.49 seconds. What is her speed? Give your answer in meters per second. So the first thing we want to do here is convert 0.1 kilometers to meters. You should be able to convert by now. For this one, I would just use the moving the decimal over method. So 0.1 kilometers is going to equal 100 meters. So basically, Florence Griffith Joyner is doing the 100-meter dash. So now let's write out our formula. V equals d over t. So we'll have 100 over 10.49. So remember, we need to use the thing we converted to here. And we end up with 9.53. Are we done this problem? No, we are not. We need to put in units, and the units are meters per second. We've got some more definitions. So displacement just means distance with direction, and velocity means speed with direction. So 5 meters, is that going to be distance, speed, displacement, or velocity? Now for these types of problems, you have to look at the units. So meters. First, does that refer to distance or speed? Well, that refers to distance. For it to be speed, it would have to have a time unit, and this one does not. So now we have to decide, is it distance or displacement? Well, there's no direction given, so it has to be distance. How about 7 meters per second west? Is that distance, speed, displacement, or velocity? Again, we start by looking at the units, meters per second. So first, is that distance or speed? That's going to be speed because seconds here is a time unit. So now we have to decide, is that speed or velocity? Does it have a direction? West is a direction, so this guy here is going to be velocity. So it's speed with direction. Let's do some more practice. So for distance, I'm going to call that D. Speed is going to be S. Displacement is going to be dP. And velocity is going to be V. Let's make that look a little more like a D there. Alright, that's about as good as I can do. Alright, this first example here, 55 mph, stands for miles per hour. So miles per hour, that contains a time unit, so it has to be speed rather than distance. There is no direction given, so it has to be speed. See if you can do this next one on your own. Pause the video if you have to. 70 meters per second east, so meters per second, that's speed. East is a direction. We've got speed with direction here, so it's going to be velocity. How about 100 miles west? Miles, that is not speed. That is distance. And west is a direction. So here we've got distance with direction. So this is going to be displacement. 400 meters. So meters here, there's no time unit, so that refers to distance. There's also no direction, so that's just going to be plain old distance, not displacement. About 17 kilometers. Kilometers refers to a distance. So I walked 2 kilometers, for example. In this case it's 17. But kilometers is going to be distance. There's no direction, so again it's just going to be plain distance. 30 meters per second to the left. So meters per second, we've got a distance unit and a time unit, so that's going to be speed. To the left is a direction, so this is going to be velocity. How about 40 kilometers south? So kilometers is distance, there's no time unit, so it's just distance, and then south is a direction. Remember, distance plus direction is going to be displacement. How about 70 miles per hour west? Well, miles per hour, we've got distance unit and a time unit. So that's going to be speed. And then west is a direction, so this is going to be velocity. Last one, 83 meters to the right. So meters is distance. There's no time unit, so it is not speed. And to the right is a direction. So this is going to be displacement. Please be ready to do more practice with these in class, and don't forget to write your summaries for your Cornell notes.